There are lots of ways scientists test their ideas. They collect data and make observations of natural phenomena. They collect samples and look for patterns. But one of the most common and powerful ways to test a hypothesis is through a controlled experiment. It's called a controlled experiment because there are two groups, the control and the experimental group. The only difference between these two groups is one variable, the independent variable. All other variables in the experiment are kept the same, or controlled. There are three important characteristics to any good controlled experiment. First of all, scientists only change one variable in a controlled experiment. That one variable they change is called the independent variable. The independent variable is what scientists think is causing something to happen in the experiment. If they change more than one variable, they can't be sure which variable is having an effect on their experiment. It's also important for scientists to repeat their experiment many times. Every time an experiment has the same outcome, the surer the scientists can be about their conclusion. In real life, there are many sources of error that can influence the experiment. To be sure that the results of an experiment were not due to error, the scientists must repeat the experiment many times. Oftentimes, they'll do the experiment many times at once. Each individual setup is called a trial. Lastly, a good experiment has at least one control group. A control group is an experimental setup that is used to compare against. It is an experiment that is set up so that you know what the results will be. Oftentimes, water is used instead of some chemical or treatment that's being tested. It's used as a negative control. A negative control because we know there won't be any reaction. A positive control can also be set up so that you know there will be a reaction. Both of these setups allow you to compare your experimental group against a known result, a positive result in a positive control, and a negative result in a negative control. So let's look at a couple of examples. The first experiment was done in the 1600s. People observed maggots appearing on rotting meat, so they reasoned that maggots must come from meat. So an Italian scientist, Francesco Redi, did an experiment. He put chunks of meat into a jar and then put the lids on some and left the lids off of others. First of all, Redi changed just one variable in his experiment, the lid, and everything else was kept constant. The meat was the same type and came from the same place. It was kept in the same location. The meat was the same age and temperature. The same amount of meat was in every jar. So these were all variables that were controlled. Redi had often observed meat left uncovered had maggots on it. He knew the results of this experiment would be, so this was his control. There was a positive reaction. Maggots did show up, so more specifically, this was the positive control. Because Redi saw the jars with lids did not have maggots on it, he could conclude that maggots did not come from the meat. They must have come from somewhere outside. We now know that flies must have landed on the meat and laid eggs. When the eggs hatched, maggots crawled out. So let's look at another experiment. Let's suppose that you needed to test whether or not a certain food had sugar in it, and you don't have access to the food label. There's a chemical called Benedict's solution that tests for sugar, and I'll just call it chemical from now on to keep things simple. If you just added the chemical to the food, it would be difficult to tell if there's sugar in the food. What should happen if there's sugar in the food? What would happen if there's no sugar in the food? So in this case, we set up two controls. The negative control contains water and Benedict's solution, so we know there's no sugar in the water, so this will give us a negative reaction. This is our negative control. The second control we set up is a positive control. We added a sugary solution and the chemical because we know that there will be a reaction. So this is our positive control. This allows you to compare the food you're testing to a test tube with no reaction and a test tube with a reaction. And by comparison, you could tell if the food that you're testing contains sugar. In the last experiment, the experimenters trying to answer the question, does soil type affect how tall a plant grows? This control is a little trickier to pick out. Another way to choose which setup is the control, or how you should set up your control, is to leave something in normal conditions. So if you're testing whether temperature has an effect on whether the way something grows, you would want a control that's kept in room temperature, because that's the normal temperature that the plant grows in. If you wanted to test whether a saltwater fish can live in fresh water, your control should be a saltwater fish in salt water. Knowing this, can you pick out the control in the last experiment?